Hello everyone. Today we will solve medium level task that called unique binary search trees. So let's start from the description. In the description we can see that we are given integer n and we should to return the number of structurally unique BST, which has exactly n nodes of unique values or from 1 to n. So let's see first example. I think we will consider only this one to make it clear. So in first example we have integers from 1 to 3, and here we have first binary 3, it's 1 3 2, second one 1 2 3, third one 2 1 3, first one 3 2 1, and last one 3 1 2. So before we solved similar task, but here we have another meaning of this task. So here we have input 3, and according to logic of this task we should get output 5. It's our it's number of our binary trees. So if our input 1, we will just it's just a root of binary 3, so it's logically output 1. So I think this task we can solve without any binary trees. Some of people create binary tree class, but here we haven't 3-node class, and we will just solve this one by one algorithm that I will show you in our compiler. So firstly, let's write the code that will solve this one, and after I will explain this code, because this task a little bit harder than others, and firstly you should see how code looks like. So let's start. Firstly, we'll create our array. Let's call it G. So length of this array, it's n plus 1. So why it's n plus 1 I will explain later. So our first element of G array and the second element of G array will equals to 1, and here we'll create for loop where our I equals to 2, because our first two elements they have values, and we will start from index 2. So our I equal or lower than n, and we will have here I plus plus. So I plus plus, here I have mistake. So here we will create second loop where we will create variable g, and it will start from 1, and it will works until it will equals or lower than I. So g plus plus. Okay, firstly, here we will make something like Fibonacci thing, but it's not recursively, and yeah, it's similar with Fibonacci because our first two elements equal to 1, but it's not Fibonacci. It's look like this, but it's a little bit different, and it differs from this one by following formula. Here, every element of our G array, we start from index 2, it equals to G minus 1 multiplied to I minus G elements. It's indexes of this array. So I think most of us think that this task is a little bit harder, and now it's not clear, but firstly let's run this one and I think it's more. So okay, here we should we missed one patternless. Okay, we didn't return the value. So okay, let's return value, and here we will return. Okay, here we will return gn. Okay. So let's run it, and what we will see. Okay, here we have one problem. Let I fix it. So what is problem? Okay, I missed this one. Well, we will not just equal gi to this value. We will sum up all these things that save it in gi index. So let's run it again. And okay, now our two test cases passed. So let's submit it, and what will happen? Oh, okay, it's accepted. So let I show you how do this one. I made presentation for you. It's a little bit harder, and I take some explanation from the creator of this formula. So these algorithms consist these statements. So gn, it's number of unique BST for sequence of length n. Our fi and n, it's number, no, it's for loop where our I between 1 and n. So I think it's clear. And as one can see, gn is the actual function we need to calculate in order to solve the problem, and gn can be derived from this for loop, which at the end would recursively refer to gn. So before I mentioned that there is no recursive. No, it's not totally recursive like the Fibonacci, but here we have a statement of recursive method. So first of all, given the above definitions, we can see that total number of unique BST gn is the sum of BST in our for loop using each number I as a root. So that is why in the following code we sum up them. So before I used just equality, so it was wrong because we should to sum up all of these values, gn values. So how it works? Our gn, it is number where all of our f1n, f2n, and until fnn, it all will sum up. And while we didn't use g0 and the g1 indexes, it's following like it's have similarity with the Fibonacci numbers. So by the logic of Fibonacci numbers, also our g0 and the g1, they are equals to 1, because in our loop we use first element and the previous element. Previous and the previous of the previous element, yeah. So as you see on the screen, we follow this logic, and finally we have this one, and we will get our result. So function of this one seems very easy, but explain this algorithm and this function is a little bit harder. So I think you got that I explained to you, and I think everything is clear. So it's all for today. Our task is finished, accepted. So thank you guys for your attention. Goodbye.